The task was print posted rate for 12,000 validation loads plus fill in the 31-day December chart for one fixed route. Both targets fall in November and December 2025 entirely after the trading window. So this is a genuine forecasting problem, not interpolation. A few things stood out first. About zero point 0.6 of the rows had negative weight values. The magnitude matched normal positive weights almost exactly. So this looks like a sign flip data entry bug. So I corrected it by taking an absolute value rather than the drop rather than dropping rows. Second validation.csv here contains 8 pickup and delivery cities that never appear somewhere in the trading, like Chicago, Norfolk, San Diego, and others. This is a real general- generalization risk that I had to design around. For splitting the data, I avoided random key folds because it would let the model see same week data in both train and fold out. That's not realistic. Instead, I use time-based split trade on January throughout August, fold out September and October. Here is the cutoff throughout September that mimics the real 2 month gap to the actual November December target that gives an honest read on generalization error. For features, I was constrained about the fact that the December file only has pickup, delivery, and distance, equipment, weight, and date. No lat logs, no market index. So I restrict the model to columns available in all three files. I tested by adding identity back in. So I sit- tested a point by adding city identity back in the row B. Here you can see, and actually made a holdout error worse, which I also confirmed dropping it was the right call given those unseen cities. I also tested adding the market and code science here, market index and code science. They gave a small improvement, but they are missing entirely from the December file. So using them wouldn't meant building a second second model just to forecast them. Not worth the adding fragility through for roughly 1.7% gain. Here, the model is history gradient boosting regressor that handles categorization and missing values natively. No heavy dependency on the time-based holdout. And MAE is about $140. M MAPE is about 6.3. Training error was close to the to that, so the model isn't overfitting the training window. Prediction.pile loads this sub prediction.pile load the same model that applies identical feature engaging with both validation.csv and the December file. Same same code path, no difference here. Here is the resulting December chart. Here is the resulting December chart. You can see the steps down rather than craving smoothly. That's expected with the tree-based model since the prediction are piecewise constant as the date moves forward. The overall downward trend still matches the session pattern from the trailing. Full reasoning is documented in the EDA notes.md here and the features experiment.py that produce this decision. Thanks for the review.